Good morning, America. My name is Jeff Gogel. Today I'm going to try and delay the inevitable extinction of the human species. The colonization of space should be the primary objective of mankind. I'm going to propose 5 space transport vehicles. A launch vehicle, an Earth space elevator, a lunar space elevator, a starship, and a warp drive. This is my proposed launch vehicle. It starts with solid fuel hybrid rockets. Each weighs 80 pounds, has 1,000 pounds of thrust, burns for 20 seconds, and costs $2,000. It is totally inert and non-explosive. And a 20,000 pound payload. We'll attach hybrid rockets and rings around the payload. 6, 19, 38, for a total of 152 rockets in the first cone. To get the payload into orbit on the 20 burn stages, stacked like ice cream cones. The launch vehicle has 18,000 individual hybrid rockets attached and weighs 1.5 million pounds. For guidance, just throttle the rockets. By stage 20, altitude is 220 miles, velocity is 18,000 miles per hour. Total cost, $40 million, $2,000 per pound lifted into orbit, 20% of current launch costs. Add a few extra cones, you have a lunar rocket. Add even more cones, you have a Mars rocket. The sole purpose of this launch vehicle is to put 1,400 tons of pre-construction material into GSO to build my first space elevator. Trajectory calculations and a launch video.
Assemble it hanging from a gantry. Raise a scaffold and attach the rockets. Attach bungee cords to the first stage and remove the gantry. Pull the launch vehicle down and release it. Ignite stage 1. And even if 100 of our hybrid rockets misbehave, we still achieve orbit.
This is my 2009 Earth space elevator. It has a base station at Macapa, Brazil, right on the equator. It has 2 elevator transfer stations. Has a platform at GSO. Has a counterweight at 60,000 miles up. Tapered support cables. And finally, 4 sets of elevator cabs, belt-driven. In 2009, I prepared a structural study for this proposed Earth space elevator. My elevator weighed 262 million pounds, including 125 million pounds for the counterweight. Tensions raised from 1.08 million pounds at the base, 10.6 million pounds at the GSO platform, and 6.9 million pounds tension at the counterweight. Of the 14 tethers I had in service, they ranged in size from 2.62 inches in diameter to 7.03 inches in diameter at the GSO platform. Estimated cost for this elevator, $40.7 billion. Into space for $100 a pound. We can do this now. We can start building this now. Here's my current thoughts. DC electrical power now drives the elevator cabs up and down the array. 157-foot diameter, Ice ball is a counterweight. 1G bolus for crew eating and sleeping. 5 mile in diameter, maybe 1 RPM. A global exhaust foam. Permanently eliminate global warming. Guarantee it. Space debris removal. 10 of these will completely eliminate all the space junk now in orbit in the first year. Debris catcher leaves the transfer station, releases the debris ball, intercepts a large piece of space junk, pushes it into the ocean. The debris ball catches smaller pieces of debris. Debris catcher picks up the debris ball and returns. Tethers are made of alternating layers of graphene flakes and diamond nanotube threads to hold the flakes together. These are covered in beryllium and alternating bands of Lexan, corrosion protection. All half-inch square, T-allowable 250 kips per tether, and the Young's modulus for all the components in here is 150 million psi. A stationary platform at 62 miles, 16 half-inch tethers. The intermediate tethers rotate maybe once a day, keep them from tangling. Up at GSO, I'll need 50 half-inch tethers. This space elevator will become the base for my Starship fleet. This is my proposed Starship. It's 1 mile in diameter, it's 2 miles long, and fusion powered. It weighs 25 million pounds and generates 25 million pounds of thrust for the entire trip. 1G acceleration. Has a skin lined with lasers and DLP reflectors. These lasers generate 1.5 terawatts of power to confine the hydrogen cloud into a fusion ball. The output of this Starship is 3 terawatts, half dedicated to propulsion. It's got a crew module housing colonists, maybe 2,000. Has an exhaust nozzle. Hopefully the only thing coming out of the exhaust nozzle is going to be high energy photons and nuclei of iron. It's got a shield at the front, regularly maintained, and a deuterium-tritium injector to generate fuel for the fusion. The Starship could be used for interplanetary travel. To and from the moon, round trip in under 8 hours. To and from Mars in a couple of days or a week, depending on conjunction. When Chicxulub 2 heading towards Earth, the Starship will go out and push it off course. Or maybe push it into a GSO orbit for mineral extraction. And here's my proposal for 2020. Interstellar travel in groups of 3. The Nina, the Pinta, and the Santa Maria. A forward exhaust port to ionize the forward trajectory and also disintegrate any particles that might be incoming. Metallic hydrogen skin for fuel, and if that can't work, maybe lithium hydride, LiH6, and a trawl net to capture interstellar hydrogen, again as fuel. Fine-tune this into a Star Wars Death Star. Obliterate Iraq in minutes with little loss of human life. DARPA, you better get here before the Chinese do. And it's a very good green energy source. Greta, AOC, a little help here. And finally, my warp drive. the first thing I have to do is go out and grab Uranus and put it in orbit around Jupiter. And then CERN LHC is going to turn this into a black hole. And then we go out to Neptune, grab that, put it in orbit around Saturn, and again convert this into a black hole. We have to take Saturn and completely reverse its orbit around the Sun and move it into a near collision course with Jupiter. And properly guided, the two black holes will crack open space-time and create a wormhole. Okay, total science fiction. But I do believe that what I proposed here as far as space travel and colonizing Alpha Centauri is doable. Maybe not exactly the way I've laid it out, but doable. In general principles that I've presented here. We need to do this for the very survival of our species. And the reason I say that, every year we wait, some madman's going to come along and destroy us all. Good luck.